Welcome to AJ Action Academy YouTube channel. In this session, I am going to discuss waves. In this, transverse and longitudinal waves. If you like this video, please subscribe to our channel. Please share your valuable comments in the comment section. Okay, let us go to the today's session. First one, transverse and longitudinal waves. First we will discuss transverse waves. The waves in which the particles of the medium oscillates perpendicular to the direction of propagation wave are called transverse waves. Here perpendicular, this is perpendicular to direction of propagation. Along the direction of propagation, transverse waves. Perpendicular to the direction of propagation of wave are called transverse waves. The horizontal string with one fixed to a rigid support and the other end is held in the hand. An upward jerk gives a pulse which travels along the string toward the fixed end continuously. So gives up and down jerk, each part of the string vibrates up and down while the wave travels along the string. Now, the maximum displacement in the upward direction is called crest and in the downward direction is called trough. Crests and troughs are formed alternatively. See, this is the picture, and in this is the upward displacement, and it is the maximum displacements are in upward direction and are known as crests. The maximum displacements in the downward direction and are known as troughs. One crest and one trough constitutes one wave, one complete cycle. This is the amplitudes, and these ups are crests and downs are troughs. From here to here, wavelength. The distance travelled by a disturbance in the medium to and fro from the about mean position is known as the wavelength. And these are crests and down one are troughs. One crest and one trough constitute one wave. The wave is moving in this direction. So every particle of the medium in a transverse wave undergoes simple harmonic motion, but the phase of the particle differ and their amplitudes are equal. The velocity of the particle is maximum at the mean position and 0 at the extreme position. So these waves are possible in solids and strings but not in fluids because they can sustain the shearing stress. Now discuss example: light waves, waves on strings and rods. Now discuss longitudinal waves. The waves in which the particles of the medium oscillates along the direction of propagation of wave are called longitudinal waves. Here, the waves in which the particles of the medium oscillates along the direction of propagation of wave are called longitudinal waves. See this picture. Now, consider a long cylinder closed at one end and having a movable piston. If a piston is moved suddenly down a small layer of air, just near the piston, air is compressed and the layer moves down and compresses the next layer. So, a compression travels along the cylinder to the other end. If the piston is moved upward in the air, layer just adjacent to the piston is rarefied. As a result, pressure decreases. So, the air from the next layer moves in to restore the pressure. So, the next layer is rarefied. So, in this way, a pulse of rarefaction moves upward. If we continuously push and pull the piston, then a sinusoidal sound wave travels in the form of alternate compression and rarefactions. Compression and rarefaction. So, at the compression, the pressure or density of the medium is maximum. At the rarefaction, they are minimum. So, these waves can be propagated through solids, liquids and gases. Now, discuss examples. waves on springs and sound waves. Now I'll discuss MCQs. First one, the unit of angular frequency is radian, radian per second square, steradian. The unit of angular frequency is radian per second. The waves in which the particles of the medium oscillates along the direction of propagated wave are called longitudinal waves, transverse waves, stationary waves, none of the above. Here, the waves in which the particles of the medium oscillates along the direction of propagated wave are called longitudinal waves. Next, the waves in which the particles of the medium oscillates perpendicular to the direction of propagated wave are called longitudinal wave, transverse waves, stationary waves, none of the above. Here, the waves are in which the particles of the medium oscillates perpendicular to the direction of propagated wave are called transverse waves. Now discuss displacement relation for a progressive wave. Displacement relation for a progressive wave. Let us discuss. Progressive wave. A wave which proceeds in the medium without being reflected is called progressive wave. This may be longitudinal or transverse wave. Plane progressive harmonic wave. If the particles of the medium vibrates above their mean position, then the wave is said to be plane progressive harmonic wave. So in harmonic progressive wave, particles have same amplitude, but the phase of oscillation changes from one particle to another. See here. Let a wave start from the origin and travel along the positive x-axis with a speed v. So at t is equal to 0, the particle is at origin passing through its mean position. So initial phase of particle to be 0. The displacement of the particle at the origin O at any instant t is y is equals to 0, t, that is equals to a sin omega t, where a is amplitude and omega is angular frequency. Consider another particle P on the x-axis at distance x from O. This is amplitude. The disturbance starting from the origin will reach the point P and starts vibrating x by v seconds later than the particle at O. See this picture, wavelength amplitude. Now, the displacement of the particle at a point P at an instant t can be obtained by replacing it t by t minus x by v. So, y of x comma t is equals to a sin omega of t minus x by v. So, y of x comma t is equals to a sin omega t minus omega x by v. So, omega by v is equals to 2 pi n by v, that equals 2 pi by lambda, that equals to k. K is called propagation constant. So, y of x comma t is equals to a sin omega t minus kx. So, this equation represents a harmonic wave travelling along positive direction of x-axis, or y of x comma t is equal to a sin kx minus omega t. Y of x comma t is equals to a sin of 2 pi by t minus 2 pi by lambda into x. So, y of x comma t is equals to a sin 2 pi of t by t minus x by lambda. Y of x comma t is equal to a sin 2 pi by t of t minus x by lambda into t, but lambda by t is equals to v. So, y of x comma t is equal to a sin 2 pi by t of t minus x by v. Also, y of x comma t is equals to a sin 2 pi by lambda of lambda by t into t minus x. Y of x comma t is equal to a sin 2 pi by lambda into Vt minus x. The initial phase of the particle at O is phi naught, then the equation of the wave motion will be y of x comma t equal to a sin omega t minus kx plus phi naught. A harmonic wave travelling along negative direction of x-axis can be written as y of x comma t is equals to a sin omega t plus kx plus phi naught. Amplitude. Now let us discuss. The maximum displacement of any particle of the wave from its mean position in either direction is called amplitude of the wave. So now phase. The phase of the harmonic wave is a quantity that gives a complete information of the wave at any time and at any position. Phi is equals to omega t minus kx plus phi naught, where phi naught is the initial phase. Phase of a wave is periodic both in space and time. When x equal to 0, t is equal to 0, then phi is equals to phi naught. Now we will discuss wavelength lambda. It is the distance covered by the wave during the time in which the particle of the medium completes one vibration about its mean position. So, distance covered by the wave during the time in which the particle of the medium completes one vibration about its mean position is known as wavelength. It is the distance between two particles of the medium which are vibrating in the same phase. Angular wave number or propagation constant k. So, the quantity 2 pi by lambda is called angular wave number. It represents the phase change per unit path difference. Its unit is radian per meter or radians meter inverse. K is equals to 2 pi by lambda. Next, time period. Time taken by the particle to complete one vibration is known as time period. The time in which the particle of medium completes one vibration about its mean position is called time period. Next, frequency. The number of waves produced by a unit time in a given medium is called frequency. Frequency is denoted by letter n is equals to 1 by t. Frequency is also defined as the reciprocal of time period gives frequency, omega by 2 pi. So, unit is second inverse or hertz. T is equals to 2 pi by omega. So, time period T is equals to 2 pi by omega. N is equals to 1 by T or omega by 2 pi. Angular frequency omega. The rate of change of phase with the time is called angular frequency of the wave. For one complete time period T, the phase change is 2 pi by T. Then omega is equals to 2 pi by T. That is equals to 2 pi N. So, units are radians per second or radians second inverse. Next, wave velocity. The ratio of angular frequency to the propagation constant, that is V is equals to omega by k or lambda into 1 by t. So, V is equals to n lambda. Units are meters per second. Relation between phase difference delta phi and path difference delta x. Let us discuss. Consider 2 points at positions x1 and x2 on a wave at a given instant. Then phi 1 is equals to omega t minus kx1 and phi 2 is equals to omega t minus kx2. So, phi 1 minus phi 2 is equals to k of x2 minus x1. Delta phi is equals to k of delta x. Delta phi is equal to 2 pi by lambda into delta x. If delta x equal to lambda, then delta phi is equals to 2 pi. So, a path difference lambda corresponds to a phase change of 2 pi radians. So, now we will discuss relation between phase difference and the time difference delta t. So, delta phi is equals to 2 pi by t of delta t. Here delta t is the time difference. Delta phi nothing but phase difference. This is the relation between phase difference and time difference, that is delta phi is equals to 2 pi by t into delta t. Now discuss MCQs. Progressive waves are waves which dash travel in a given direction. Discontinuously, continuously, regularly, irregularly. Progressive waves are waves which continuously travel in a given direction. Second one, which of the given physical quantity related to the particle in wave motion continuously changes? Amplitude, frequency, phase, time period. Here, in the given physical quantity related to particle in a wave motion, phase changes continuously. Okay. Thanks for watching this video.